Hello and welcome. This is Chapter 6, Section 4 on partial fractions. So our objectives are dealing with rational functions and making them a simpler fraction by using partial fraction decomposition. We're also going to just look at some basic rational functions and their graphs. So we're going to do a quick example going back to Chapter 2, looking at our asymptotes. So the first step is, let's draw this one. This is 2x over, if we factor it, it's x plus 4 and x minus 2. So if we think about it, this has vertical asymptotes. So this one, f of x right here, will have asymptotes at x equals -4 and x equals +2. So we're looking for those. So anyone that has vertical asymptotes at -4 and +2, well, this one doesn't. So if we think about it, it's not graph A. Well, it could be this one, so we'll cross it out later if it isn't. So it could be this one. It's definitely not this one. It could be this one, and it's not this one. So the only ones with asymptotes like this are the ones with the check marks. So now what we're going to do is think about its horizontal asymptote. So remember, our horizontal asymptote is looking at that. So when the numerator is higher than the denominator as in far as degrees, so it's x to the first over x squared, we will always have a y equals 0 horizontal asymptote, which if we look at it, it's not this one, that's not at 0. But it is, in fact, this one, and it is, in fact, this one. They both have zeros going across. And again, I'm going to draw those verticals at -4 and +2, -4 and +2. So that is what we're doing with the asymptotes here and here. So it could be one of these, graph E or C. Now, the last thing to do is just substitute it in a point. So if I just say, well, let's plug in 4, notice how, in this case, it is negative if I plug in 4, and it's positive if I plug in 4. So just plug in 4 to this and see what we get. So if we do f of 4, well, in this case, we get a 8 over, let's see, we get 4 squared plus 2 times 4 and minus 8. So we end up getting, let me rewrite that 2, sort of that squared here. Terrible, but oh well. So this cancels out here, but we have 8 over 16, which is 1/2. So it's positive 1/2 versus negative 1/2. So in this case, graph C is our answer. Also notice that you could plug in 0. If I plugged in 0, this would be 0 over something, which would have it intercepting. If we think about f of 0, it is in fact equal to 0. So it does actually, both of those actually go through that. So that doesn't really help us in this case, but we want to choose this one because if I plug in this, I get a greater than a 0 answer here. So now we're going to think about the rest of it. So let's look at the last one. So when we rewrite h of x is in fact equal to x squared plus 2. We're going to factor out a 2, which gives me x squared minus 2x minus 3. Now notice the bottom is still factorable, so we can simplify this to still x squared plus 2. That is irreducible, it does not factor. But the bottom will be, what, x minus 3 and x plus 1. So therefore, we have a vertical asymptote at 3 and vertical asymptote at -1. So if we look at those, so verticals, let's go ahead and draw it at 3 and -1, which is good. This one also 3 and -1. And this one is also at 3 and -1. Notice how it's x squared, if we think x squared over 2x squared, so it actually has a, so if we write those down, this would be my horizontal. They're the same degree, so we just do x squared divided by 2x squared, which is a positive 1/2, which if you look at it, all of these have a positive 1/2 here. Now, what I would do next, let me move this up just out of the way so we can look at it a little bit better, is think about, well, what if I plug in 0 to this? Well, the top is just 2, the bottom just turns into 2 times -3 times a positive 1, which gives me a negative 1/3. So again, if I plug in 0 here, this is gone, it's just 2. Plug in 0 here, it's I need to close that parenthesis. Sorry, I plugged it into this one. So I put in a 0 here, I get -3, I get a positive 1 here. So again, just plugging in 0, we should get this, which we look for that. So at 0, it should be negative 1/3. At 0, it's definitely not this one. Again, these ones were not it just because they don't have the asymptotes, but we do have a negative 1/3 there, and it's definitely not this one, so it already eliminates it all the way to graph F. So we have graph F for that one and graph C for that one. So our main focus will be actually taking those graphs or those equations and breaking them apart into simpler different things. So for example, if I had, so decomposition of this will be break apart into simpler fractions. So the idea is just to have two simple fractions versus one complex fraction or simpler fraction. So if I have 2 over x times x minus 1, I could break it apart into two different fractions like a over x plus b over x minus 1. And we'll eventually have to find what a and b is. So the idea is whatever is on the denominator, we're going to break it apart into x and x minus 1. So instead of putting it together going this direction, we're actually decomposing it or breaking it apart into two separate fractions because we can look at this and then we can look at this easier. So this process of decomposing fractions is not that challenging. It's just a little bit of algebra. What we're going to do is we're going to take our two whatever different factors on the bottom and put them as separate things. So it'll be like a, just pick a random variable like a, and we're going to put that over x, and then we're going to add it to just some b value over x minus 2. Now what we're going to do is we're going to solve for a and b. We're going to try to figure that out. And the best way to do that is whatever is on the denominator, we're going to multiply by that because we want to get rid of the fraction. So what we're going to do is we're just going to multiply by x times x minus 2 to both sides of the equation. So now when this multiplies over here, they actually will cancel out or reduce to 1 if you want to think about it. So we just have -4. And now if I multiply this to here, notice how the x's would actually cancel out because 1 will, this is all to the numerator to the top, and the x's go away, but the x minus 2 still remains. So you're going to have a times this x minus 2. And then plus, we're going to have b, and notice how in this case, if I multiply this over here, the x minus 2's will go away because 1's on top, 1's on bottom, and the x will remain, so it's just b times x. So now we have an equation without any fractions. So now we're going to have to simplify this. So we'll distribute that out. This doesn't have to distribute, it's just b times x. So if I rewrite this, this is -4 is equal to ax minus 2a plus abx. Now we're going to combine like terms. So this is something x. We're going to put a and b together, which is just a plus b. So we still have -4 over here, and ax plus bx is just a plus b x's. So again, if this was 2 and 3, it'd be 5x, or 2 plus 3, which you can write it in parentheses. We don't know what they are yet, so we're just going to write them in parentheses like that, and we have minus 2a. So now what we're going to do is we're going to do this kind of one-to-one thing we've been learning or doing all year long, starting from chapter 0 when we had imaginary and real parts. So notice how this is in front of x and this is in front of the constant. So this is a constant, and notice how there is 0 x's right here. So we're going to just set it equal to 0. So we're going to say this a plus b here is going to be equal to that, and this -4 is equal to this. So we're going to be like, hey, a plus b is 0, and we're going to be like -2a is equal to -4. That will help us solve for those. So if we divide by -2 to both sides, I get a is 2. If I plug that 2 back in here and subtract it over, I get b ends up being a negative 2, because positive 2 and negative 2 is in fact 0. So now I actually have my two variables, a and b, that I can plug back into my original thing above. So the idea is my answer to this, so we know that negative 4 over x times x minus 2 can be broken apart into a, which is 2 over x, plus, well, in this case, minus, because b is negative 2, so I'm just going to put that outside, and then minus 2 over x minus 2. So I can break apart this fraction into two separate fractions, 2 over x minus 2 over x minus 2. So let's try one more together, and then I would like you to try one. So we're going to break this apart again. So the only difference is we have negative 2x plus 9, and we don't know what the bottom is, but we know that if I factor out, there's an x in both of them, I can take out the x, and I have x plus 3. So sometimes you have to kind of factor it out. Sometimes it will be trinomial here, where you'll have to factor it like normal, but they both share an x, so take it out. So now we can split it from here. So it's nice to break apart the bottom. So we have negative 2x plus, sorry, we are going to put a up top. So a over the x plus b over the x plus 3. Now, some of you might ask, like, does it matter if I put x here or x plus 3 over here? It doesn't matter. The idea is addition is commutative, so I could have put this over here and this over here, and it's still the same thing. So it will just solve and make the a's and b's swap. So if I switch these, the a's and b's will switch as well. So it will end up being exactly the same. So the idea is we have this. So we're going to multiply by this to both sides. So we're going to multiply both sides by x times x plus 3, this times x plus 3. And what you're left with is just that numerator of negative 2x plus 9 is equal to, again, x times x plus 3. The x's would cancel out or reduce to 1 in this one, and you have x plus 3 times a. So we have a times that x plus 3. And then this one over here times this, the x plus 3's go away, and you're just left with plus bx. Now we will simplify this. Negative 2x plus 9 is equal to ax plus 3a plus bx. Again, combine the like terms. So we have negative 2x plus 9 is equal to a plus b times the x value plus a 3a. Now again, the whatever's in front of x is going to equal to itself, and then whatever the constant is equal to that. So we have these two things. We have a plus b is in fact equal to negative 2, and we have 3 times a is in fact equal to 9, where we can simplify. A is just 3, and then if you plug it into this one, we subtract it, gives me b is negative 5. Now all we have to do is plug it back in. So we would end up getting a value of 3 over x, and then since it's a negative 5, we're just going to put the negative instead of a plus sign, and we'll put 5 over the x plus 3 as that final answer here for that partial fraction decomposition. So please try this one, see if you can break this apart. Notice how it's just a negative 18 on top, which is nice. There is no x value, so it's 0. My thing is maybe I can help you factor this if you are stuck on that. Again, if you rewrite this, this is negative 18 over, we're going to have 2x and x. The factors of negative 4, that will multiply this, and you kind of have to guess and check. There's a few methods you can do. I'm guessing it's 2 and 2 or 1 and 4. I think it's 1 and 4 here. Now think about it, 2x times this, we want more negatives, so I'm going to put a negative here, so that's negative 8, and a positive this. So try this one on your own. This is how you would set it up though, so see if you can work through this and get an answer. I'll have an answer shortly. So if you did it, you should have got 4 and negative 2 for both a and b, and then it should have turned into this as my partial fraction decomposition.